Hello, everyone. Nice to see you again. Um, so today we're going to talk about a big topic in MDM, and this is called VEE, Validate, Estimate, and Edit process for the meter reads. So I break that down into four sections. We have an overview on what VE rule can do, and it's, as I said, it can be break down into validation rules, estimation rules. We talk through that, and at last we have a look at the entity relationship diagram. As always, we do. So first part, let's look at what is the V rule. So we talked about meter read in the last session. I think meter read is one of the most important process in MDM because meter data management is mainly around how the meter is validated, loaded. If the meter is a meter read is missing, how do we estimate it? So to achieve that, VE play a very big role in terms of this process. So for VE process, for VE rules, we will have VE groups. So you create groups and then you have rules within the group. For each VE rule, you have effective date. So potentially, based on the effective date, you could have multiple rules running at just different dates. So in those cases, which you can have a future rule in the group VE group, which can be run in a future date. Um, and one important feature of VE rule is you can build eligibility criteria based on that. We use that quite often because remember the VE group is set on top of the measuring component. So it is a generic process, and it is a group will be run for all the measuring components or potential measuring component type. In that case, if you have a measuring component set, let's say a half interval measuring component, that could be a smart meter, it could be a AMR meter. Based on different device features, you potentially could have different rules for estimation, validation, etc. So that this is where eligibility criteria becomes really important, and that can make the difference in terms of which rule to run at runtime. Next, we look at VE matrix. So basically, VE matrix is deciding which VE group will run based on the factor value. And this is, again, another great feature for branching the VE decisions, which so let's say uh, for the factor, if that's based on the service point, if it's energized service point, it will run a particular set of rule. For de-energized uh, service point, it could be run another set of rule. So remember these eligibility criteria and the factor value, they can be based on different objects. So they are not just restricted on device or device config. They could be based on the installation event. If the installation event is on or off, or service points. So it can traverse through this whole V model in terms of the data structure. Okay, next one is about declaration. VE rule can be declared on the, as we said, on the machine component type or on the machine component specifically. So on the machine component type, that would be the fallback rule, will be the default rule to run for this type of machine component, and you can override it on individual machine component if required. Last one is the severity. So if we are running a VE validation rule, if it failed, we can tell the system for particular type of error, it's informational. For some of them, they're issue, which means the current meter reads will go to issue, but it will continue. Or you will need to terminate it if there is any exceptions happening. For example, the meter read validation expecting a profile value, and the profile value is missing, which means potentially all the estimations could be at risk to be wrong. So in those cases, you want to terminate the process rather than carry on. So these are the severity we can specify on different rules. Okay, so next let's look at the validation rules. There is a lot of base product rules has been provided by Oracle MDM or C2M, which you look at MDM parts. There is online C2M documentation. You can look at all the rules. There's a whole list of validation rules and estimation rules. I'm not going through each of them, but I'm going to take some examples which I think they are really important. They are always being used in the project to deal with the generic issues, and many projects has been extending these rules to add more aspects from the data perspective, adding attributes and building custom logics. But these ones are the base ones I have seen being used the most frequently. So the first one is the generic high-low check. So this algorithm compares the average day usage or the max value of the current initial measurement data with the ADU. So ADU is a concept in these rules, in a few rules actually. So what ADU actually means is the average daily usage. And how do they calculate it? Is actually, if you look at a scalar reads, say we have last month's end to this month's end, let's say 31st days, and if the value is say 62, then average usage, a daily usage is 2 kWh per day. So in those cases, you can validate your reads if there is a read coming in between the months, and you use the ADU to compare whether it's too high or too low. And the high-low percentage can be specified, as we can see in the screenshot. Over here, the high tolerance is 130% and the low tolerance is 70%. So with a simple configuration, you can easily tell whether this how the rule actually works, and it just works very simply using the ADU as using the linear calculation for the scalar reads. Now, the second one is the zero consumption check. Well, that's even easier, more easier than the high-load check because it will basically check whether the consumption is empty, which, well, okay, so one concept here is a lot of people think the consumption check is the reading check. No, that's actually not the reading check. The consumption means my current reading is same as the last reading, which means there is the consumption, the reading hasn't changed, so the consumption stay at zero. Okay, so let's be very clear on what it means by the reading and what it means by the consumption. Another one is negative consumption. As we know, the meter goes forwards. I mean, it's very rarely we are going to see a negative consumption. So very often you want to make sure there's no negative consumption happening. Now we have seen three rules which can technically um, they can all do negative consumption validation. Like we look at high-low check, zero consumption, and negative consumption. But why there are different rules provided by Oracle, it doesn't actually mean we have to use all of them, but it does give you the flexibility. As we said, we have this exception severity. Okay, so maybe sometimes the zero consumption we just erase that as informational because it is possible that the consumption is zero if there is no usage. But it is quite rare and it's quite probably wrong that something is going wrong if it goes to a negative consumption. So the severity should not just be informational. That should really be a severity in this case. Okay, I mean it should really be an issue in this case, and that should be flagged to the user, and then check with the meter, etc. So although you have different rules doing similar things as we are talking through, but the here we can utilize these severities to do different notification, different level of notification to the business. Okay, let's go through the estimation rules. The first one is interval average estimation. So interval in UK, if we always talk about half-hourly meters, that is every half hour we will have a consumption coming from the market, and every day we are having 48 values. However, sometimes when we receive the reading from the market, remember the reading comes in not just with a number, but also with a condition. Okay, so zero with a condition actual is very different from zero with a condition missing. Okay, so this it make a huge difference in terms of how the system works. So if you load a rate which is consumption zero and actual, okay, there's no estimation gonna happen. But if you load the rates with some of the values on the zero and the missing, if you run run estimation rules, they are going to estimate these ones. So this is one of the example. It is averaging out the interval with the ones on actual. So it fills the gap by averaging the consumption around it in a particular period. Okay, so next one, it is another way of estimation interval consumption. It's as I said, it will just draw a linear line, and then it's called interpolation estimation. Um, and it is also working in the same way for the interval if the consumption is 0 and missing. Now the last one is the scalar estimation. This is very often used for scalar because if we have a missing interval, or let's say we have a meter reading at the end of the month, but the customer for some reason demand a bill in the middle of the month, a ad hoc bill, let's say 20th of the month. Now, you don't have actual read. So what the system is going to do is going to create an estimate read on the 20th based on this end last month's meter read, last month's end read, and the next month's end read. Draw a line, see where 20th fits in that graph, and then decide what is the scalar reading for that date and work out the consumption. Okay, so we briefly talked through the scalar and interval validation and estimation rules. And let's look at the relationship diagram. Over here we can see, as we said, the VE group is set on the measuring component or the measuring component type. The VE rules is a part of the group, and VE eligibility criteria can be set on the VE rule. VE rules can throw exceptions with different severities, like informational issue and exception. Terminate. And then we look at the factor values because one feature it has is using the VE matrix to decide which group of VE rule to run at runtime based on the factor value. Okay, that's the end of this session. Thank you very much, and see you next time.